So this might be a little bit weird because you can hear me, but you can't see me. I'm there with you. This lesson, you're going to need a few things. So this is your list. Grab these things, pause the video if you need to before we get going. But you're going to need your foldable when we started in class last time. And the handout that we started also in class last time. We're going to be working with that. And you should have a new handout. It's called 3.3 Graphs of Polynomial Functions. So we're going to be move into that later in the video. Have all three of those. I'm going to post a link to this video so that you can review it on your own time if you need to. It might be helpful to get a chance to see it a second time if I'm going too fast for you. Let's get started. So last time we met, we talked about how a polynomial has a lead term, and that term can determine what the ends of the polynomial will look like in a graph. This one was degree 5, so that was kitty corner, but the negative coefficient it has told us that the first end would be up and the right end would be down. And that was all from the lead term, but this was when we were in standard form. Now our next example, if you just take a look down here, we want to do the same thing. We want to figure out the long run behavior, and I'll remind you that long run behavior is another way to say the end behavior. The problem we're faced with, though, is a polynomial, but it's not in standard form. I don't know what my lead term is because I have a bunch of factors here. So if I'm going to determine my lead term, I'm going to need to multiply all of that out. So before you panic, take a look. I have done the work for you. Now you should panic because that looks like a lot of work. And to tell you the truth, it was a lot of work. So I would like you to learn a little shortcut that will help you figure out what the lead term is without having to do the full multiplication out of figuring out all the terms of the polynomial. The only one we're really interested in is this lead term. So notice this is 10x cubed. Let me show you a quicker way to get it. What you're going to do is basically recognize that at some point the lead term is going to be found by multiplying the lead terms of all the factors together. So what you're going to want to do is just take one factor at a time and write them down. The first factor is this 2. I'm just going to write that one down. And actually, I lied a little bit. Let me back up. You're going to take each factor and take the lead term of each factor and write it down. So out of these two factors, x is the lead term. I'm just going to pull that out and ignore the minus 1. The lead term of this is a little out of order, standard order, would be the 5x. Pull that out, and the x minus 2, x is its lead term. These are the lead terms from all 4 factors. Now, all you're going to need to do is multiply. Oh, hold up. I lost one. That was 5x in the middle. Let me back up. That's 5x. Okay, so what I was saying is you're going to now multiply all of these lead terms from each factor together, and you get 10, and there's 1, 2, 3 x's, so 10x cubed. 10x cubed would be your lead term if you took the time to multiply everything out. Would you rather do that or this? I think it's easy to see. So here's our lead term, but we figured it out just with this nice shortcut. So what is the long run behavior or the end behavior? You can think of this graphically. You're going to have a cubic, so they're going to be kitty corner. It's a positive coefficient. It means it's going to start down on the left, and when it's done, it'll be up on the right. All right, so that's a nice shortcut. We'll see that in a few more examples. Now let's review what we did about horizontal and vertical intercepts. So let me remind you about those two. The horizontal intercept, remember that's your x-axis. These are the X-intercepts. And we're going to solve an equation. We're going to solve the equation where f of x is set equal to 0. In this case, wouldn't be f of x, it would be g of x, but still, we're going to put 0 is equal to this product of these factors. Each of those factors, you know, can individually be set equal to 0. So you're going to have 3. You got 3 variable factors. This 2 isn't going to make any difference in the intercepts, but the ones where we see the x variable, each of those will give us a solution. So x equals 1 is from the first factor. In this factor, I'm going to show all the steps to that. We're going to set it equal to 0. That means subtract the 3 over and divide by 5. So x equals negative 3/5 is another intercept. And the last intercept where x is equal to 2. Okay, now remember, you don't write those as equations. Your x-intercepts are this list: 1, negative 3/5, and 2. You want to write those as coordinates of points, just do that with 0 as the y-coordinate. Okay, now there's a second part to this. They also want us to figure out the vertical intercepts. So these are where our y value is. This is where the y-axis is involved. So on these, you're going to evaluate. You're just going to plug in 0 for x. Evaluate f at 0, or in this case, g at 0. So in this case, we would plug in g at 0. All the x's become a 0. The first factor is still 2. In the second factor, I got 0 minus 1. I just like to look at that as minus 1 or negative 1. Forget about 0 minus 1. The next one, the 3 will be there still, but 5x is going to 0 out. So it's just that constant 3. And the last term, when x is 0, we subtract 2. That term's or factor is going to be negative 2. Multiply all that together, and you got a positive 12. kind of interesting, I want to point this out. Your Y-intercept is always the constant at the end of your long string of terms in your polynomial. You can see that right here. Here's my constant. It was plus 12 after it all got multiplied out. That's going to be your Y-intercept, and there's your lead term, all without having to multiply it all out. Okay, so for your answer, you can say your Y-intercept is 12. Or you can give it, like I mentioned over there, you can give it as 0 for X, 12 for Y, and list it as a coordinate. Okay, so let's go to the foldable and just kind of jot that stuff down. In this section, this lower section closer to home, we're going to talk about the vertical intercept. So I do want to remind you, that's the last thing we just did. We're going to evaluate where the function is an input of 0. You're going to solve that. And for your horizontal intercepts, these are your X-intercepts, I want to remind you that you don't have any more than n. And remember, n is the degree of your polynomial. So you'll never have more than n roots. What was the degree of our last example? The degree there was 3 from our lead term. And then look at this. How many X-intercepts did we get? Count them up. There's 3 there. Okay, so you'll never have more than that. In order to find them, you're going to solve the equation where f of x is outputting or equal to 0. Okay, now the next thing I want to highlight is this idea of multiplicity. I'm going to do that with an example, and we'll come back and write up about it. But multiplicity basically is referring to the number of times a root occurs. So these are going to have something to do with your X-intercepts or your zeros or your roots. So on our next example, if you flip this, they're asking us the same question about the long-run behavior. And so that's where I'm going to do the shortcut. I'm just going to say, all righty, what is my lead term of each individual factor? But this factor is special, and this is where multiplicity comes in. This factor has a square on it. Is that really one factor? Does that just mean x minus 1? It doesn't. It means x minus 1 times a repeated factor of x minus 1. So this is the idea of multiplicity. How many times does x minus 1 occur as a factor? It occurs twice. So we say it has double multiplicity. We'll talk more about that. Let's go to each factor, pulling in the individual lead terms from each of the factors. This will be -2. This one's x. This one's x. This one's x. But this isn't just 1. This is 2. This is x. And you have to take that exponent squared for that last factor. All multiplied together gives a lead term that would be -2x to the 4th. That's your lead term. It's not your answer, but you don't have to multiply it all out to figure that out. Okay, what your long run behavior is anytime we have an even power or even degree, we know we're going to be down, down, or up, up. In this case, with that negative, it's going to be down, down on the two ends. All right, now let's figure out the horizontal and vertical intercepts. Horizontal intercept, we're going to solve the equation 0 set equal to our function rule. And don't forget that square. It's the most important part. All right, -2 never will equal 0. X will equal 3, and that will cause a 0 here. A 0 for this would have to happen if x is -4. And this factor, which is actually 2 of the same thing, is where x would equal 1. And I'm going to put a little times 2. That's times 2. That's a reminder to me that this was a repeated root. So I'm going to say it has double multiplicity. Vertical intercepts. Vertical intercepts, we'll do that here. We're just simply going to plug in 0 for all those x's. So h with 0 plugged in. Bring down my -2. My first factor will 0 out that x. It'll leave me the constant, -3. The constant from this factor will be the 4. And the constant from this factor is -1. It's 2 factors. Let's make sure it's -1 that we bring in the square. So that'll square out, make positive. This is positive. Multiplied all together, I'm getting 20, a positive 20. All right, so let's check that because I happened to take the time to multiply this function out so I could write it in standard form. It was a bugger. You are very welcome. Here it is. There's all my work. So you can either do that or learn the shortcut. I think it's a pretty clear choice. But what did we get for our lead term? Does it match what I got when I did the calculation? And here is the constant for my y or vertical intercept. We got both of those, except apparently I can't multiply. Oh my gosh, how embarrassing. I've done it again. I was adding that. So that's 6. 6 times 4 is 24. My bad. All right, what would a lesson be without an arithmetic error in it? All right, so what is the big deal about these multiplicities anyway? Let me have you come to the foldable, and I want to talk about that with you. All right, so even multiplicity versus odd multiplicity actually tells you a lot about the graph of a polynomial. So I got that even multiplicity when I had the function, I was going to write y equals x minus 1, and there was a square on the factor, which really means it's x minus 1 times a repeat x minus 1. Now what that's going to do in a graph is it's going to show a point. Here it would be where x is 1, and we know that the function value is going to be 0 there. But we also know that this multiplicity right here means that the graph, when it's making all its twists and turns, is going to act like a little parabola right there at 1. So it may come from down here. It's going to come and it's going to hit that 0, but rather than crossing through, it's going to just hit it, touch it, and turn right back around like a little parabola would do. Now we're going to have some pretty fancy graphs, so you need to remember that if you get this double or maybe any even power really, that your graph is going to just touch the x-axis at that point and turn back around rather than cross through. Now graphs will cross through the x-axis often. They do it when there is odd multiplicity. So if I had something like y equals x, let's say minus 10 to just the first power, and then I also had x, let's say minus 12, but that was cubed, then I would have the x-axis would produce some zeros. One would be where x is 10, and the other would be where x is 12. And at each of those points, my graph is going to hit the x-axis. Well, this single multiplicity, that's just a power of 1. That factor occurs once. When that happens, my graph is going to cross through rather than just touch like it did here. It's going to cross right through that and hit it and then keep passing through it along its way. A lot like a line does. If there's a cube on it, another odd number, then this one that was produced from that factor, this is going to act like a little cubic function. So it's going to kind of bend like a cube does, curve up, something like this, have that little concavity change. But notice that anytime the multiplicity or the degree of the factor is odd, the graph will pass through the x-axis. If the function has a factor that's got even multiplicity, so the repeat is an even number, that's going to be a time where the graph just touches and turns rather than passing through. One of my classes used to call that a kissing point because the graph would come and kiss the x-axis and then turn away. Okay, so let me do a few more examples to clarify this idea of multiplicity. And to do this, we're going to go to your new handout. And I think we're going to skip, for the sake of time, we're going to skip that first example, and let's go straight into this example. We're asked to find the vertical, or well, actually the horizontal and the vertical intercepts of this function. And it's already factored. So factored form is nice for finding these horizontal intercepts. We're going to set the function equal to 0 and solve. So 0 is equal to 1/3 x minus 1 repeated twice, x plus 2, and x minus 3. Now, why don't you save a little room on this side because I'm thinking I might want to just graph this one. So I'll do that. Okay, so the zeros, none from the constant factor, but this factor here gives x equals 1 as a 0. I'm going to make a note that it had a repeat, so I'm going to double multiplicity it, little times 2. This is x equals -2, and this is x equals +3. So my x-intercepts as a list would be the numbers -2, 1, and 3. And 1, we want to talk about that being special with the multiplicity of 2. All right, I'm changing my mind. I'm probably not going to graph this because I don't have enough room. Because we got to get vertical intercepts. So vertical intercepts, we're simply going to plug in 0. So f at 0. That means all the constants in each factor come down. So 1/3 is in there. The constant from this factor is -1. That's a repeated factor, 2 of those. The constant here is 2, and with 0 in for x, that gives me a constant of -3. Now let me try multiplying this out again, because I did not do so hot last time. Okay, I am looking at positive. Those will cancel. I'm thinking it's +2. I'm crossing my fingers that I did that right. All right, I changed my mind again. I think I am going to graph this because we didn't use the space up above. So in order to get a graph, I need to kind of lay out what my x-axis looks like. So I'm going to do that here. And this is going to be a pretty rough sketch. No big deal, not perfectly sketched. My 3 x-intercepts are -2, +1 with a double multiplicity, and a 3. And I'm not even scaling that right. Okay, so these points are on the graph where the x-axis meets the graph. The y-axis is sitting right here, and our graph has to hit the y-axis at 2. Right there. And something that would be really helpful to know is the ends. What do the ends of this graph look like? So I wasn't asked to do it, but we're going to do it anyway. What do the ends look like? So let's do the trick to find the lead term without multiplying all this out. grab each of the factors' lead term. So 1/3 comes down. Lead term of this is the x. Make sure you get the square. Lead term here is another x. Lead term here is another x. We're looking at 1/3 x to the 4th, which puts my graph looking like up, up. Okay, now I'm ready to graph this baby. So here's the way this works. Starting up on the left, I need to come down and hit this intercept. In fact, not just hit it, but I need to pass through it because it was just the standard single multiplicity. This did not have any repeats. So this passes right through that intercept, kind of like a straight line would, but it's not a straight line. Kind of looks kind of straight. Now, crap. You guys, I have a mistake again. This is so embarrassing. I did it here again. This is -2. Who caught it? Talk to me tomorrow. I probably owe you a big apology, but I caught my own mistake because I'm not headed the right place. All right, so forget this 2. -2 was that y-intercept. Let me plot it. Forget about this. All right, let's try this again. So we were back on the ends. We were coming from here and crossing through, and we do need to hit the y-intercept, but we also need to hit the x-intercept here. So that means that somewhere we're going to have to make a turn. Now, you do not know where the turn is going to happen. That is something you need calculus to answer for you. All we know is it's going to make a turn. So I'm going to come down, and I'm not going to grade you guys one way or another where your turn happens, but you do need to make a turn, and you do need to hit the intercept. And as you come up towards this intercept, this is where the multiplicity comes in. You can see me kind of curving my pen because it has the double multiplicity. So I need to be a little parabola there. It's just a kiss point, come back down. It's coming from below. It's going to touch and turn right back down around down into the negatives. All right, we've got one more intercept to hit. So we got to make another turn. We make another turn somewhere. I don't know if it goes low or high, but somewhere you're going to make a turn and cross through. This was single multiplicity. Just cross right through and end your graph up. It just as we predicted. We predicted it would be up, up. We also know the degree is 4, so how many turns are possible? Remember, the number of turns is 1 fewer than the degree at most. So we cannot have any more than 3 turns. You can count 1, 2, 3 turns. And we have got 3 intercepts, which is okay because we had an opportunity for 4. And some people will count that double multiplicity as 2. So 1, 2, 3, 4 if you count the double multiplicity. All right, let's see if we can do these last 2 examples without any arithmetic errors. That's my goal. Okay, now these just say sketch a graph. So it's helpful to have all that information that we listed before. Let's start with x-intercepts. Are there any x-intercepts to help us? So setting this equal to 0. The first factor has an x in it. X is going to equal 0 for that factor. X is going to equal 1 for this factor, double multiplicity. I think I'm obsessed with x equal 1 with that. And x equals -3 for this one, just regular -3, no multiplicity involved. How about y-intercept? Let's go f at 0, and this is where I always get messed up. Okay, so the first x is going to be 0. That'll zero it out. The second one will be -1 squared. The last one is +3. I think I can't mess this one up. 0 times whatever is 0. So y equals 0 is our y-intercept. Okay, and last, let's think about the ends. What would these look like? Lead term, first factor, is -2x. It's the only term of that factor. Lead term of the next factor, which is a repeat, is x, repeated twice, so x squared, and last is x. And multiplied all together, it's -2x to the 4th, which makes the ends go down, down. Okay, graphing time. I like to start with the x-axis, put on the zeros, which are -3, 1, double multiplicity, and, oh, I missed 0 right here. That's going to be a tight turn right there. Okay, each of these points, the graph better be hitting the x-axis. That also means the y-axis is right here. I don't have much to do on that because I've already got my y-intercept. Y-intercept was also 0. With the ends going down when we start, and by the time we're done, we better be headed down again. Okay, I would like to plan it before I draw it. I'm going to come from below. I'm going to cross through that first intercept. That's a cross-through point. I'm going to make a turn somewhere so that I can cross through this intercept, make a turn, and this is a touch and turn intercept. This is kissing the x-axis before it turns around. It's a little parabola right here. Okay, so cross through, touch and turn parabola, and then head down all the way when you're done. You can kind of see that happening. So here we go. Coming up through, make a turn to go through again, a turn, touch and kiss, head right back down. There's your graph. Don't panic too much because you still don't know how high the peaks or how low the valleys are. That really is a calculus question. You won't be able to answer that without a little calculus tools. All right, one last example, and I hope this is enough for you that you'll be able to be successful as you practice it on your assignment. Walk right through the steps with me. Let's start with finding the x-intercepts, setting the function equal to 0. We got x minus 2 cubed, that's a repeat root, and x plus 1 single root. That's going to make x equal 2, but it counts as 3 different answers that are all the same repeated. And the second one, x is negative 1. So we'll build our x-axis with those 2 points in a minute. All right. Plugging in 0, we'll get our y-intercepts. So plugging in 0 is going to take everything out of there except negative 2, repeated 3 times as a factor, and 1. So negative 2 cubed is negative 8. I'm feeling confident. And finally, let's figure out what these ends look like. We only have 2 factors, the first one, lead term, I'm forgetting. Lead term is x, and x is going to have a cube on it because it's that same factor 3 times, times another x for a total of x to the 4th lead term. Think about what your ends are going to look like. This time up and up. All right, it's graphing time. Here we go. Lay out your x-axis. You're going to want to put negative 1 to the left and 2 to the right. Remember, this is triple multiplicity. Holy cow, before we do that, let me find my foldable. What are we going to do? Where we have triple multiplicity, that's like this factor that was repeated 3 times. So this would have said times 3, triple multiplicity. We're going to make a little cubic kind of shape through there. And on our single multiplicity, we'll have it more linear as it passes through. All right, let's see. So I'm going to put my dots. These are my intercepts. Those are my targets. Y-axis, let's go right here, and let's just put negative 8 on there with a point to shoot for. And we are ready to put the ends on. So make sure that your graph starts up, and when you're done, you're still going up. All right, so starting up, we're going to come from above, and we're going to pass through this intercept, kind of linear, and then let's go head towards that 8. And maybe it comes past the 8 before it makes its turn. But now, as you come up this way, do that little kind of wiggle that the cubic graph does as you come up towards that point. It's a little wobbly there. Not my best graph, but you get the idea. If I was with you, I'd show that to you on the computer so you can verify. All right, so there's our graph there. Okay, it is your turn. Help each other. And if you guys have any questions, you certainly can text me, and I can help you over a text. Or if there's a really hard problem you get stuck on, I might be able to just make a video for you and send it to you. So I can send you links, and the link to this video is on the website. So go ahead and check it out if there's any extra you need. Good luck with it. I'll see you soon.